Now, by now, this is probably the fourth or fifth time that you've seen very similar PowerPoint to this one, because slope is not a new thing for us. But it is a very important concept to all algebra, because a lot of what you do in algebra, and even once you start getting up into pre-calculus and calculus, is going to deal with the change in slope. Slope is a measure of steepness of a line. There are types of slope. We have positive slope, you have negative slope, you have zero or no slope, and you have undefined slope. Now, notice with each of these, we're reading from left to right. So as we're moving from left to right on a coordinate plane, if the line is going up, it's positive. If the line is going down, it's negative. If the line is flat, it's zero or no slope. And if the line is vertical, it is undefined. It does not create a function. Slope is sometimes referred to as a rate of change between 2 points. The letter M is used to represent slope, which is slightly different from what you learned way back in 6th grade, where you were first introduced to K, which was your constant rate of change, and K was equal to Y over X, the change in your y's over the change in your x's. Now, the only reason that worked, change in your y's over change in the x's, is because you had direct variation. Your line was always going through the origin. And so as your y's increased, your x's increased at a comparable rate. If given 2 points on the line, you may find the slope using the formula m is equal to y2 minus y1 over x2 minus x1. Notice again, we have our y's in the numerator, our x's in the denominator. So it shares some commonality with k. But when we are developing slope, we are using 2 points on the line because the line may or may not be constant. Sorry, may or may not be a constant in proportionality, in other words, going through the origin. Find the slope of the line that goes through the points 3, 4, and negative 6, negative 2. Since you should be familiar with finding slope, I'm going to get you go ahead and get started. All right, you should have ended up with something like m is equal to y2 minus y1 over x2 minus x1. That's your formula. It should always be your starting point. I generally like to see students label their ordered pairs so that they are consistent on grabbing the 2 and then the 1, but that's up to you. Our y value of negative 2 minus our y value of 4 over our y value of negative 6 over our y value of 3. Negative 2 minus 4 is negative 6. Negative 6 minus 3 is negative 9. Negative divided by a negative is going to be positive. Both terms are divisible by 3, so we end up with 2 over 3 as our slope. If given the graph of a line, you can simply use the slope by recognizing m, which again represents our slope, is equal to rise over run. So as we look at an example on a coordinate plane, we have a starting point, and you're always looking for starting points that intersect perfectly with grid marks. If they intersect perfectly with grid marks, that means both your x and your y value are whole number integers. And so you can move from one whole number integer to another whole number integer and end up with fractions that are only dealing with whole numbers. So from here, we are able to move up 1, 2, 3, 4 units to be parallel with our second ordered pair. And we are able to move over 1, 2, 3, 4, 5 units to finally end at our second ordered pair. So we said that m was equal to rise over run. And we have risen 4. And we have run 5. So our slope is 4/5. Well, what about when you end up with a curved line? Is it still possible to find the average rate of change? Well, let's think about the change in the lines. On this side of the graph, our change is decreasing. On this side of the graph, our change is increasing. So increase or decrease, and what the actual slope is going to be dependent on additional information. So it's a lot more helpful when I actually give you what that additional information is. F of -1 and f of 1. I want to know what the change is between those two particular points. So we know f of -1 is talking about the x value being -1. So I want to come back on my x-axis to -1 and then go either up or down until I find the graph. That would be right here. F of 1, I want to come forward on my x-axis to 1 and go up or down until I find the graph. Well, the graph hits right there, so I don't have to go up or down. It just simply is there. At this point in time, we just need to know the slope of the line that goes through those two ordered pairs. So again, I would do rise over run. Now, when you're doing rise over run, be careful to make sure that you're paying attention to units. Notice this bottom dot or ordered pair is at -1, -4. So we have risen 4. And then we have run 1, 2. So our rise over our run is equal to a rise of 4 over a run of 2, which is equal to 2. Now, if we can do that on a quadratic graph, surely we can do it on an exponential graph, right? A little bit more tricky, but we can still get it done. So we have f of -1, come back 1, and we need to find our ordered pair. Now, we talked about in class, I went ahead and used a standard f of x is equal to 2 to the x graph. And so your ordered value here is 1/2. All right, f of 1, we come forward 1, and we go up until we hit the graph. All right, and so that is, we can see down here that each up and down unit is 1, so that's up 2. So we have gone up 1.5, we have gone over 2. Rise of 3/2, a run of 2. So I have 3/2 getting divided by 2. We want to keep it, change it, flip it. 3/2 times 1/2 is equal to 3/4. Between those two ordered pairs, we have a slope of 3/4. Now, since I've attached the line, we can check that. Let's look for our next intersecting point. Our next intersecting point is way down here. So I can see I'm rising 1, 2, 3. And I'm running 1, 2, 3, 4. We sure do have a slope of a line that is 3/4. Find the average rate of change from f of -4 to f of 1. Now, I find it easier to find average rate of changes when you are given a function than when you're given a graph. Because as we know with exponential graphs, some of these values are not always whole numbers plotted on a graph. Sometimes we're guessing at like 8/9. It's going to be really close to 1, but not quite. And so from the graph, you can't get an exact dictation of what value is being represented. But when you have the actual function, you can, because we can simply take the f of x value and plug it into the function. So f of -4 is equal to 1/4 raised to the -4 plus 4. Well, we learned the other day that a fraction being raised to a negative power flips the fraction, keeps the power. So we simply need to know what 4 to the 4th power is. 4 to the 4th power is 256 plus 4. So f of -4 is equal to 260. I could certainly label my ordered pair as negative 4, 260. All right, that's one ordered pair. Let's find the other. F of 1 equals 1/4 to the first power plus 4. Well, 1/4 to the first power is 1/4 plus, I want to add something to a fraction, so I want a common denominator. The common denominator is 4, so I need to multiply 4 to 4 to get 16/4, which is the same as 4. And that's going to equal 17/4. Now, 17/4 is not the prettiest number, but we can certainly work with it. So we have the ordered pair 1, 17/4. And finally, we're ready to find our slope. So m is equal to y2 minus y1 over x2 minus x1. I have a first ordered pair. I have a second ordered pair. Again, order doesn't matter. I could certainly have labeled the bottom one my first one and the top one my second one. What matters is that I'm consistent on which one I'm calling first and which one I'm calling second. So m is equal to y2, 17/4, minus y1, 260, over x2, which is 1, minus negative 4, which is going to become positive. And so we end up with 5 in our denominator. The numerator, however, is not quite so pretty. So let's clean that up. 17/4 minus, we need to multiply 260 by 4 so that we can determine what our common denominator is. I'm sorry, what our numerator is when we have a common denominator. 1040. And so we want to combine 17/4 minus 1040. And we get negative 1023. All right. Negative 1023 over 5 cannot be simplified because there's not any common multiples. So our slope is negative 1023 over 5. Now, if you need to change that to a mixed number so that you can determine which value has got a greatest rate of change, then that might warrant the extra step. But otherwise, we were just all asked to find the average rate of change. We have found its value as an improper fraction simplified. That is sufficient enough. All right, which rate of change is the greatest? Go ahead and pause the video again. Work through these questions. And then when you're done, come back and watch to see your solution. All right, welcome back. So f of 0, we need to plug in all of these f values to find out what the f of x values to find out what the corresponding y values are. So we're going to use the same function every time. Starting with f of 0, I'm only going to do this once because we did it on the previous, and then we're going to transition over into me giving you solutions. So f of 0 is equal to negative 2 times 3 to the 0th power, because we're replacing the x with that 0, minus 5. Well, 3 to the 0th power is 1. 2 times 1 is 2. Oh, sorry, negative 2. Negative 2 minus 5 is negative 7. So f of 0 is equal to negative 7. That means I could say that 0, negative 7 is one of my ordered pairs. Now, again, I mentioned I'm not going to go through and model how to solve every one of these functions. You can check your answer based on the ordered pair. So when we plug 4 into the function, we're going to get negative 167 as a solution. When we plug 3 into the function, we get 3 and negative 59. When we plug 4, we already looked at that answer above, negative 167. When we plug 2 into the function, we get 2 and negative 23. When we plug 5 into the function, we get negative 491. Now, if you're struggling with plugging in values into a function and solving, that's order of operations. We probably want to get together during ILT time to work out some order of operations problems so we can help you get stronger at that. Well, now we're going to use our slope formula. M is equal to y2 minus y1 over x2 minus x1. So for each set of ordered pairs, we're going to find the slope. Negative 167 minus 7 over 4 minus 0 is equal to 4 under negative 160, which is equal to negative 40. Next, we have negative 167 minus negative 59 over 4 minus 3. It's always nice when you have a denominator that simplifies down to 1. Under negative 108. Last, we have a negative 491 minus negative 23 over 5 minus 2, which is going to be equivalent to, what is it, negative 468 over 3, which certainly looks like it will simplify to negative 156. All right, we found the rates of change. Let's go ahead and state that as a whole number, negative 108. We found the rates of change, but now we're asking the question, which one has the greatest rate of change? And generally, we tend to think of greatest as, hey, it's got the steepest positive number. No, we want to think of which one has the steepest overall number. So, the steepest overall number can be determined by the absolute values of each of these, 40, 108, or 156. Well, which one has the steepest overall value or absolute value? That's going to be the 156. So the change from f of 2 to f of 5 is going to have the greatest rate of change.